That's good. I always feel like the graph is the easiest part, but we are different people. So I took a lot of time on these first ones because I was trying to show you the graph at the same time, and I should have had it pre-typed in, but I didn't. But every one of these, well, 1 and 2, it was just the y value. If you, like, always don't forget about direct substitution. But if you plug it in and you get 0 over 0, it really almost always means that there is something that you can do. It does not mean the limit does not exist. It means you have to factor or get a common denominator or do number 5, and we'll do another one of these together in a minute because I was stressed on time and going really fast on that one, that if you see a square root, usually in the numerator, and you plug it in and you get that 0 over 0, which is indeterminate form, then you have to know this technique of multiplying or rationalizing the denominator. So this, we talk about conjugates a lot in Algebra 2 and Pre-Cal, but if you multiply by that conjugate, it will cancel out the square root and almost always give you a value that you can work out. Later on, when we learn about L'Hopital, you could use L'Hopital's rule here, and you don't have to know this trick, which is why I'm not stressing, like, it's why we're not going to spend weeks on this, because once we learn L'Hopital, you're going to be like, I'm never factoring again, and you're going to do L'Hopital, but I like to factor. The other one that I didn't get to in the video is one that looks like this, which looks really scary, but this is kind of a preview to something that we're going to look at in Unit 2, and they're going to see this stuff with H's, and you maybe have a memory in Pre-Cal when I made you do stuff. It didn't have a limit part, but you had to plug in an x plus h and do a bunch of work, and all the h's canceled out, and I'd always say, get the h out of here. No memories of that, maybe? That was also, like, it's like a preview of calculus, okay? Eventually, we're going to learn what it means, but for now, we're just practicing it, okay? So this one, step 1 on this is, if, I'm not going to plug it in, but if I plug 0 in here for h, we have a problem, because I don't even care what happens on the top. I would get 0 on the bottom, and I can't divide by 0, which means I need to do something to simplify this. So step 1 is we want to just work out the top, all right? What if I have an extra paper for you, Lily? I do not. Yeah. Maybe you want to just write this down somewhere, and then maybe I can print out the homework for you. I just like you should write it down on a piece of paper. And you can always just put it in your notes, right? So step 1, I have to work this out. And this is always something that people forget. Remember, x plus h squared is not just x squared plus h squared. It means there's 2 of them, right? Like, that means x plus h times x plus h. So you have to distribute. So you get x squared plus xh plus xh. You're going to get that twice, so that's going to be 2xh in the middle. And then h times h is h squared. And if you write plus xh, that's okay too. Then I'm going to distribute the negative 3, so I get minus 3x minus 3h. Then I'm going to distribute just this negative, so I get minus x squared plus 3x to the third. Do you agree with me on that? Oh, just kidding. Plus 3x. Oh, I don't know what just happened. Okay. 3, just plus 3x. I was multiplying x squared and 3x. I don't know what I was doing. But right now, when we're trying to take a limit, if the limit exists, there should be some simplifying we can do. And on these problems with h, everything without an h usually cancels out. So if you don't get it to cancel out, you go back and check your negative signs. But look, we have a positive x squared and a negative x squared. So that's going to cancel out. We have a negative 3x and a positive 3x. So I would have caught my error in a minute when I didn't have another x to the third. So look what's left on top. I'm going to rewrite it, but you can wait for a minute if you don't want to rewrite it. But what I have left is this. So do you agree, since everything that's left has an h in it, I could factor the h out? And that's where if you notice that right away and you want to do that at the next step, you can. Eventually I will as well. But if I factor the h out, then we can cancel those out, right? It's kind of like a fancy way of factoring. And now, since there's no h in the bottom, we can take the limit. And the limit says, find a limit as h goes to 0. So notice this one's a little different. There's an x in there. We don't know what x is, so x is going to stay x. And everywhere there's an h, I'm just going to put in a 0. What's wrong? So my answer to that limit is a function. It's 2x minus 3. And in Unit 2, that will make more sense. But right now we're just practicing the process, having no clue what it represents. Yeah.
I didn't realize you wrote the limit part.
Ah.
And I guess I'm really tired. And I was like in my head, I was like pause so I could like stop typing. And I'm like, I can't.
Okay. So there's, I don't know if you've looked ahead, but there's like 8 million problems in this section to practice. And so I might have to go get Lily some problems to do. We're not going to do all of these. I wrote out which ones I want us to practice today.
Well, this is what I was going to do tonight.
No, I can print a new copy of it. I just don't have one. So I'll print a copy of these pages.
She can just run back.
Yeah, it keeps going, all right? And so here's the ones we're gonna do. And also, I don't know about you, I write big and I feel like I run out of space a lot. So we're not gonna do all of these. I mean, you're welcome to go back and do as many as you want. But we're gonna do 1 and 3 and 7 and 9. It's a lot of odds. Well, because 5, we're going to learn about trig tomorrow. And 11, and 13, and 15. Some of these are just direct substitution. So, like, I know it seems like a lot of problems, but, like, number 1, you literally can just plug the number in, right? And if you want, we can do 7 or 9 together to practice another square root one if you want to do one together before you get started, or I could do number 14, but I tried to space them out because I know I write really big, so if we're not doing this one, you can use both squares for that one problem, right? But don't worry, there's more. Turn the page. 19 and 21 and 23 and 27, and then turn the page again.
We're gonna know how to do it by the end of it.
I also think we learned like 4 different versions of it, and we're just timing the format like.
And 29, and one more. 39 is the one with the H's.
This one's fun. Let's go.
We were like, where is it at?
And if you really can write small enough, 40 also has the H's, but I know I can't write that small.
That's good.
I will also tell you, if you look the answers up, they only showed work on the odd answers, so it's not they give the answers to the even ones, but there's no work to follow. So because there's no space.
Give us.
I didn't. Well, I think I maybe gave you 1. 30. No, maybe I didn't. No. I purposely gave you odd ones, yes.
So.
And so I gave you odd ones, so if you're checking answers, that you can see the work that they did as well to go with it. But you're welcome to go back and do any of these. But do you want to do a square root one together, or you want to just start? All right. I don't know, 7 or 13?
I'm not there.
7. Oh, okay.
Tiebreaker.
7's my favorite number. So
7.
that's
My favorite 7. Only because.
So again, when you're doing these today, direct substitution should be your first method. But when I plug 0 in there right away, I can see on the top I would get square root of 7 minus square root of 7 which is 0 over 0. And if I get 0 over 0, that's called indeterminate form, it means I can do something else. And if I see square roots, that almost always means I can rationalize the numerator. And in Algebra 2 and in Pre-Cal, we always rationalize the denominator, right? Like we didn't want a square root in the bottom, so we'd move it to the top. But to get this to cancel out, the issue is I need that x to cancel out. So to do that, I'm going to multiply by the conjugate of the square root. And the conjugate is just exactly where the square root is, word for word, except for that middle sign is going to change. So in this case, that minus is going to change to a plus. So I'm going to write really big. I'm going to use up 3 boxes. So I'm going to take the square root of x plus 7 minus square root of 7 over x. And I'm going to multiply by the square root of x plus 7 plus the square root of 7 on the top and the bottom. Because remember, if I multiply by the top and the bottom as the same thing, I haven't really changed the value, right? I'm just multiplying by 1.
I love that word.
Well, I just realized I should hold it if I want anyone to hear me. So, on the bottom, the point is I want the x to cancel out. So I'm not going to ever work that out. Like, I'm just going to rewrite that as x times the square root of x plus 7 plus the square root of 7. Like, that's going to stay there. But the point of this is that the top should cancel out. And depending on how much work you need to show, you could have a lot of work here. But I'm just going to, over here to the side, if I have the square root of a plus the square root of b, you don't have to write this necessarily, and I multiply by the conjugate, really it's just a difference of 2 squares. I'm throwing the square roots in there just to show you. But remember, the point of changing that sign in the middle is that the ugly part, the middle part cancels out, and everything that's left should work out nicely. So square root of a times square root of a is just a. This is going to cancel out with because you're going to get minus square root of ab plus square root of ab. That's going to be the middle part. And then square root of b times negative square root of b is minus b at the end. So every time that middle part's going to cancel out, and we're going to get something nice that we can deal with, something that we can break apart. So that's why we multiply by the conjugate, and this is why I don't show a ton of work. It's why I didn't show a ton of work on the video. I just do the first and the last because I know the middle part's going to cancel out. So when I take square root of x plus 7 times square root of x plus 7, that's just x plus 7 because the square roots cancel out. And skipping to the end, if I take negative square root of 7 times square root of 7, that's just 7, or that's square root of 49, but it's minus 7. You're with me on that? So I leave out the middle part. If you want to write the middle part out and cancel out, you can, but I encourage you to know that it cancels out. It saves a lot of work. So that's subtracting, because that's this. Negative square root of 7 times square root of 7 would be like negative square root of 49, which is just minus 7. So on the bottom here now, I have square root of x plus 7 plus square root of 7. Look what happens. 7 minus 7 is 0. So on the top, I'm just left with x. And I have an x on the bottom. So do you agree that I can cancel that out? I'm out of space already. So then it's just 1 over the square root of x plus 7 plus the square root of 7. And now I can take the limit. So the point of all this algebra that we're doing today, whether it's factoring or whether it's this square root stuff with the conjugates, is I want to take the limit as x approaches 0. So now I can plug 0 in there for x, and I get 1 over the square root of 7 plus the square root of 7. Well, what is the square root of 7 plus square root of 7? Square root of 14? No! No! It's just 1 over 2 square root of 7. So it's like an x. If I have x plus x, it's 2x. If I have square root of 7 plus square root of 7, it's just 2 square root of 7.
I didn't see the plus sign.
I plugged in 0, right? I'm taking the limit as x goes to 0. So that x becomes a 0, and then I just get an answer. So if you want, you can do number 13 next because it's the square root one. A lot of the other ones are the direct substitution and the factoring, but feel free, go back to the beginning, and then maybe when you get there, see if your brain can remember it on how to do that. So my advice is try it before you look at the answers, or maybe try like two or three and then check those 2 or 3. I mean, I don't want you to do all of them wrong and get them all wrong, but try to do a few, check with each other also, but then also you can check the answer.